Okay. Hello and welcome. My name is Eric, and this is a live stream hosted on owncast.eom.dev, owncast.eom.dev. That is a self-hosted streaming service, and today I want to show you basically how I am doing that and how a lot of this works. It's pretty complicated stuff, and I am going to glaze over quite a lot. So if you are not familiar with some of the software engineering stuff that I'm going to be showing here, I can imagine this will be a very confusing live stream, but I'm going to just do the best I can to show what I have relatively quickly. We'll just jump right in and see where it goes. So you are watching this on owncast.eom.dev or somewhere else later that looks like this. You might not be watching this right now, and I may have uploaded this to YouTube, or you may be viewing it on something else that I've put up, but that's the basic idea here, is that I am streaming to that platform. And I have deployed that platform onto a service that I want to show here. So, boy, we're really just jumping in. This is a list of some of the services that I have deployed. I'm glazing over a lot. I have a big computer. Let's take a look at it. This is the first stream. I'm a bit nervous. I practiced, but you know. Here we go. Dell PowerEdge T640. This is a big server that I have. It's over there in my closet. It's actually kind of loud, so you might hear it right now. That can be kind of annoying at times, but whatever. This is a lot of fun. What's important about this is that it has a pretty powerful processor. I think it's a Xeon, I don't remember the number, but it has 16 cores, and we have 18 bays for storage here. Now, in the one that I have over there, I'm only using the first 6 bays. The first 2 of those 6 are configured into a RAID 1 array, which is going to be mirroring data on both of them. So anything you write to the first one gets automatically copied to the second. This RAID array just stores the operating system, which is Debian, and I do the RAID array for just some basic data protection. If one drive fails, the whole system does not die. I can just replace that one drive using the spare one as the backup in between. The next 4 are configured into a RAID 10 array, which is going to do mirroring and striping. So if we think about these 4 drives here, data will be mirrored between 2 drives. So like half of what you're going to write will go to one drive and half of what you write will go to the other drive. And then when you try to read it, it will read them both at the same time, so you get basically twice as fast input-output operations on the array. And then that grouping of 2 is mirrored onto the second grouping of 2, so you get the same kind of automatic backups that are provided in the RAID 1 array. So what we have here is a really big computer with a big processor and a lot of data storage. And what I have done is installed a few packages and configured a few services on this computer that make hosting this Owncast stream possible. We can find that stuff in Gitea. Gitea is like GitHub, but you can host it yourself. This is another service that I'm hosting on my server, and what we're looking at here is kind of just my dashboard. There are several repositories listed here. Some of them aren't really relevant to what we're talking about today. I will show them more in the future, but let's see. Most of them are actually going to be submodules of this one, software infrastructure. And this repository contains Ansible playbooks that automate the deployment of all of the stuff that I want on my big computer. So one of the ideas here is that this network took a lot of effort and thought to design, deploy, configure, and get running. And should something happen where it gets shut down or I need to start again on another computer, I don't want to have to go through the entire process of setting everything up again. So ideally, with this repository, and not actually just ideally, in reality, it does this. I can basically hit a button and it will take my computer from a base installation of Debian to running all of these services, making them available over the internet. It's pretty cool. So, at risk of reading code to people on a live stream, which I imagine would be riveting, I'm going to go through some of the things that are in this playbook. Again, if you're not familiar with Ansible playbooks, this is going to be kind of confusing, not a very good introduction to Ansible. I would recommend learning a bit about Ansible and how it works before trying to understand what's happening in this stream. But we can basically see what's going on here just by reading it. We have a few steps, and these are the steps that Ansible is going to execute on the remote machine in order to do what we are trying to do. I'm going to skip over this first step. As we can see, it is running on workstations. That is referring to computers like the one that I'm using right now to host this stream. Not to host it, but to conduct this live stream. The one that is running OBS and the one to which my microphone is plugged in. So in terms of actually hosting this network, this section here isn't super relevant. We're going to skip it. We'll go right to the hypervisors. A hypervisor is just a computer that is running virtual machines, which will be part of this. We will get there when we get there. Okay, so I have some groups of machines here in my inventory. Let's take a look. Here are the workstations, as previously mentioned. Here are the hypervisors. We have the T640, and I actually have another PowerEdge server, an R350. It's quite a bit smaller than the T640, and I have intentions to use it within the network, but at the moment it is not really being used, so I'm going to ignore it. That said, when this play here is running on hypervisors, Ansible is going to execute all of the tasks and roles and all that stuff on all of the machines in this group, which is both PowerEdge servers. As you can see, we're going to be deploying some virtual machines later, and there are quite a number of them, but we can skip over that for now. So, when we are initializing a hypervisor, just some basic things happen. I have some setup scripts for Debian, a personal user environment, and NVIDIA drivers, which don't actually work at the moment. It has a substantial GPU in that big computer over there. What is it? An RTX A6000. And it doesn't do anything at the moment. I just keep getting this RM init adapter failed error, and boy, that's frustrating. But I'm going to have to table that problem for another time. So we're going to move on here. We basically just configure a basic setup for a server, just giving it these three things here. Again, I said I wasn't going to go too much into Ansible, but I feel I should explain that a role is a group of tasks. So like what we can see, let me see if I can find a good example. Here is just a task. We're going to update the apt repository and then install each of these packages. Whereas here we have a role, which is going to just contain a group of tasks. So this is not an Ansible tutorial, but just so you know, this is what that is. Anyway, once we have those basic things set up on the system, I wanted to configure network file systems, which basically just lets you take a directory on your machine and make it available over the network. There's a lot more to it than that, but this is also not a network file systems tutorial. So, and in fact, I didn't really have to do anything to get that running. I just used Jeff Geerling's NFS thing. What is it? Ansible role. He publishes that, and basically I was able to just use the configurations that he defined, and works pretty easily. The reason I did this is for that 32 terabyte RAID array. I want that to be accessible to the virtual machines, and later on the cluster nodes that we will be deploying here. So we take that 32 terabyte RAID array and we make it available on the network. And then we take our hypervisors and we are going to prepare an environment for virtualization. This is for QEMU, virtual machines, and not a whole lot to say about that because it's pretty standard. There are some things you have to do to configure your system before you can use QEMU, and like getting your network ready and making that configuration persistent. So this just installs those packages and does that basic configuration. The actual deployment of the virtual machines is a little bit more interesting. So let's see. First of all, we have templates. This is a thing that is just part of Ansible. We can create this in this templates or directory. I can define this Gitea template for a libvirt virtual machine. If you have used libvirt, you've seen these, what are they? XML files that will define your virtual machine and contain all of its properties. And combining that with the templates available in Ansible, you can use host vars to configure the virtual machine that you want, which is a little bit confusing. So again, not an Ansible tutorial. Each machine that each host that Ansible is going to execute tasks upon which Ansible is going to execute tasks, excuse me, there are going to be a group of variables associated with that host. So let's see if I can show in our host variables, we can see, let's go to the Power Edge because that's going to have more. Here are just some variables that are specific to the Power Edge T640, and these are going to be combined with any group vars that are pertinent to groups to which the Power Edge T640 belongs. So we can see hypervisors. Do I have, yes, hypervisors. Here are some additional variables. All of those get kind of grouped together to create a dictionary of a bunch of different values that define this particular host. And the reason I'm telling you about that is our Gitea template here for a libvirt virtual machine. I wanted to be able to do, well, it actually shows up more in the group vars, but I can treat virtual machines as distinct or discrete Ansible hosts and give them group vars and host vars that will populate the values in this template here. So we can use pretty standard libvirt interfaces along with standard Ansible template abilities, and it gives us kind of a clean way to define virtual machines and deploy virtual machines. Another thing that's interesting about this is that the host vars for the hypervisors contain lists of which virtual machines are going to be running on them. So here are all of the virtual machines that run on that T640. And what happens is we just use a loop. Here it's talking about the networks, but down here we are looping over the guests. And so once we download our base image for these virtual machines, which is the Debian Cloud image, Debian 12 generic to be specific, once we download that cloud image, and we can just say we download a copy of it for all of the guests that run on this hypervisor, and then we can resize them according to the well, in this case they're all going to be 16 gigabytes, but we can use the host vars for each item, the host vars for each virtual machine to, it's kind of confusing to so like this task is execute, excuse me, I got confused myself there. This task is executing on the hypervisor, but it needs to access variables for the virtual machine. And since I store a list of the virtual machines in the host vars for the hypervisor and actual host vars for the virtual machine in the virtual machines host vars, you can kind of loop over things and access variables in this way to build this network. That was really not clear at all. I apologize. This is live, so you're going to get stuff like that. Point being, I'm able to template out the virtual machines that I want to deploy and use this Ansible task to configure them and deploy them. A couple things that are interesting. I'm using Cloud Init to configure them, which is kind of standard for these Debian 12 generic AMDs. And is there anything else interesting about that? I don't know that there is. Yeah, I have to reboot them after I create them because I resize it. So the resizing only takes effect after you reboot. So at the end of all of this configuration stuff that happens, we reset it. And then I have to do a manual step. The first manual step in this whole process, which is kind of cool, but also disappointing. So once all of the virtual machines have been deployed and resized and then restarted and they're available, Ansible is going to need to execute tasks upon them. So we need to SSH into each one so that it doesn't need to ask us if we trust the key, and because that causes problems. When you try to just let the playbook continue and you haven't first SSH'd into them, it actually fails because it doesn't recognize these hosts. So once they are running, I manually SSH into each one, tell it to trust the identity, and then I can press enter and we continue along. Okay. At this point, we have pretty much configured the hypervisor as much as we are going to. All of this was stuff that's running on the hypervisor, in other words, the T640, and from here on out, we are going within the virtualized network. We're going to be running things on the virtual machines and later on a cluster. So, similar to at the very beginning where we installed this user environment on the hypervisor, I am going to again install the exact same user environment on each virtual machine. And that's the benefit of our Ansible roles. We can just put all of the tasks for this user environment in one role, and we can say execute all of them on the virtual machines. And yeah, nice and easy. Once we have installed my user environment, we are going to configure a Kubernetes cluster. And if you're not familiar with Kubernetes, this will again be a pretty confusing live stream. This is not a Kubernetes tutorial, so I would recommend a bit of background on that beforehand. To give it a sentence, it is a package for cluster computing. So now that I have divided my big computer into a bunch of smaller computers, which I didn't tell you exactly which ones, but now that I've divided it, I'm going to put them back together into a cluster so that they will all work together, which seems kind of stupid when you just say it like that, but there's a good reason to do it, and we'll get there. By the way, 15 is the number. There are 15 virtual machines running on the big T640. The reason for that number is that the processor that it is running, that it has 16 cores. And so each core can be one virtual CPU. And so I say so 15 virtual machines, and then we leave one core available for the host operating system. Those 15 virtual machines are configured into this Kubernetes cluster, and that needs, I know that there's things on here that say like alpha, beta, gamma. It's because I plan to have more clusters in the future, and indeed started off with 3 clusters of 5 nodes, but eventually ended up having 1 cluster of 15 nodes. And the way this is organized is that your Kubernetes cluster is going to have a control plane and workers. And at the moment, I have all of those virtual machines on the T640. This is where that R350 comes in. It would have been a better idea to put the control plane on the R350 and all of the workers on the T640, just to separate some tasks a bit. I didn't do that when I first set this up, so that is something to be done in the future. Now then, Kubernetes. There are a few things we need to do before I start that sentence, let me finish a previous one that I didn't finish. Why would I want to take a big computer, cut it into 15 smaller computers, and then put those 15 smaller computers back together? The reason is for automation and resource management. Having done this, I am now going to be interfacing with Kubernetes, which is going to abstract a lot of stuff for me. So when I get to deploying the services such as Owncast or indeed Gitea, as we are seeing right here, it's very easy for me to just say, hey, Kubernetes, run Gitea, and I need it to have this configuration and these resources. And it will just find where it's available in my cluster, where I have the compute resources or the storage resources, and it will kind of put all of that together for me. It also allows me to change the cluster, so I can take nodes away and add nodes to it, and those do not necessarily have to all be running on the same machine. They just happen to right now. So it's kind of a way of allowing resource management. It's an abstraction on said resources to make it easier to deploy things. It's resilient to changes in the network, so if you remove nodes or add nodes, it will handle that accordingly. And it also kind of does some automatic scaling stuff, which I have not played with much. Again, we'll do that in the future, but there are a lot of good reasons to use Kubernetes, and there are a lot of good reasons to use Kubernetes over a suite of virtual machines. Are there a lot of good reasons to run Kubernetes over a suite of virtual machines all on one computer? Potentially less, but the idea here is that it can grow. I can add more clusters. I can add more machines. I can add more virtual machines. This whole network that I have developed here is capable of change and able to be developed as my needs develop. Okay. How do we install a Kubernetes cluster? Well, fortunately for us, it's not going to be too hard, thanks to our good friend Jeff Geerling. Again, there are some preliminary tasks that we need to take care of to enable packet forwarding, kind of similar to what was needed for setting up virtual machines on the hypervisor. A lot of those same steps need to be done to configure the virtual machines for cluster computing. Once that's done, we basically just need to run Jeff Geerling's containerd and Jeff Geerling's Kubernetes Ansible roles. Very simple. They kind of just install themselves from there. I don't think that he has made a in-depth tutorial on how he configured those, but it doesn't really matter. We don't need it. We can just use the Ansible role. So thank you, Jeff Geerling. And what I have done is configure this to install for each individual cluster. Now, again, at the moment, I conceived of this as having 3 clusters, but through the course of deploying services and developing the network further, these 2 were cannibalized into the one alpha cluster. Woo. Didn't plan on that being an amusing name, but oh well. Okay. So at this point, we have our Kubernetes cluster fully installed, and we can begin deploying things to the cluster. So we've started with just a big raw computer, divided that into our 15 virtual machines. We've configured those into a cluster, and now we're going to tell our cluster to do a few things. First thing I do is install a package called Helm, which is, if you're familiar with Kubernetes, you probably are familiar with Helm. It's kind of like an app store, really bad example, but it's easy to install services like Gitea. I installed Gitea using a Helm chart. Again, this is not a Helm tutorial. This is, I don't know what kind of tutorial this is. This is a crazy tutorial. But anyway, we install Helm, and then we're going to put some kind of infrastructure stuff into our Kubernetes cluster. First, we need to add repositories to Helm. For each of those, I'm just going to skip that part because it's just adding repositories for Helm charts. And let's talk about the actual things that are being deployed. NFS Provisioner. This is where the network file system comes back in. That was done on the hypervisor, the T640 for the 32 terabyte RAID array. That was configured into a network file system share, which is then picked up here in Kubernetes as the NFS provisioner. So what I can do with Kubernetes is I can say, I want to deploy Gitea, and I want it to have a terabyte of storage. And it will just put that storage on my 32 terabyte RAID array. So anything that I have saved as data in Kubernetes gets saved automatically to the NFS provisioner. Do I want to show that just yet? Not really. We'll get there in a minute, so let's skip over that. Just know that this is where the network file system and 32 terabyte RAID array becomes available to the Kubernetes cluster. Okay, we can see here that it's taking it from the T640, and we have our path at data, which is where I've mounted the 32 terabyte RAID array, which I've said a few times now. Anyway, next we deploy Metal Load Balancer, and this is kind of specific to running your own Kubernetes cluster at home. Kubernetes services can be deployed in a number of different ways. If you're not familiar, again, this will be confusing, but you have your cluster IP, which is a network address that's only available within the cluster. You have a node port address, which is that it's going to use the IP address of basically the hypervisor, and then just some port on that IP is going to be forwarded to the service that you're trying to access. And those two kind of suck. So the other option is load balancer, which will give a discrete IP address to the service that you are trying to deploy. That's the best option, but for homegrown Kubernetes clusters, that's not always easy and not always possible. When you try to deploy a load balancer service, it'll often just hang waiting for an IP address, waiting for it to be provisioned, but it never comes. And so MetalLB allows you to provision those IP addresses. So if your router can handle it, if your router allows for a downstream IP assignment, I forget what the name of that specific feature is. It's in the MetalLB documentation, I'm sure. But so long as your router is able to handle allowing this downstream service to assign IP addresses, then deploying MetalLB will allow you to use that load balancer service and get a distinct, discrete IP address for any services that you are deploying in Kubernetes. Now, my router actually can't handle that, so I had to buy another router. I use AT&T for my home network, and let's see. The Ubiquiti Edge Router 6P. This gentleman here looks like that. What I ended up having to do is taking my AT&T router, which I'm required to use by AT&T. I had to plug my home internet into that and then snake this long cable all through my apartment here, all the way over there, and plug it into this guy, this edge router, and this can handle that IP address assignment, and then that is connected to the PowerEdge servers and actually a separate Wi-Fi router, which is giving Wi-Fi to the computer I'm working on right now. If that wasn't enough of a digression. So MetalLB supports two different ways of providing a pool of IP addresses for it to use. One is BGP and the other is layer 2. And here I have the configuration for BGP, but that didn't work. So this is a little bit out of date, and I actually am using the layer 2 service, which is slightly worse. The load balancing quality there is, I'm not going to go into the details of how it works, but it's a little bit less efficient in its load balancing as opposed to BGP, which does a better job. So I tried to deploy BGP, but it didn't work right away, and I've debugged quite a lot at this point, so I just went with layer 2, which kind of worked right out of the box. And if I need those performance improvements, I can switch to BGP later. I have it right here, in fact. So this needs to be updated to reflect my actual layer 2 configuration. And that is a good point to make here, is that the idea with this Ansible playbook is that it should describe the system as I want it. And do I want to go into item potency here? No. Well, yes, let's do it. So the idea is that once this whole thing has executed, I should be able to execute the same playbook again on the same hypervisor with all of the steps for deploying the virtual machines and all of the steps on those virtual machines and all of the steps for deploying the cluster and all the stuff on the cluster. I should be able to run this entire playbook again after it's already running, and it should just kind of one step at a time say, that's good, that's good, that's good, don't do anything, don't do anything. It'll just kind of skip over each step and confirm that everything's good. That's called being item potent. It is not going to execute the same task twice if it's already running or if it's already there. It doesn't create duplicate resources. So this file should define the system, the network, the PowerEdge T640, whatever you want to use your Ansible playbook for defining. It should define what you actually want, and the execution will handle whatever changes need to be made in whatever direction to make that a reality. Ideally, sometimes it fails, but that's kind of the goal. Okay, let me take a sip of water. Gotta hydrate, folks. So, we have deployed our layer 2 peer, not BGP, and the next thing that we deploy is Ingress Nginx. This is an HTTP proxy. Previously, if I wanted to host multiple HTTP services, such as Owncast.eom.dev and Gitea.eom.dev from one network, I would need to manually deploy. I was using HTTPD Apache and manually configure these, reverse proxy routes to all of the services that I want, and handle the SSL certificates therein, which can get very confusing. This does it automatically. So I can, as I am deploying a service, I can just tell it to create what's called an ingress resource, has the name potentially gitea.eom.dev, and it automatically handles creating those reverse proxy routes for me, in this case in Nginx. So Ingress Nginx is pretty great. Next is Cert Manager, which handles the SSL certificates. So along with my ingress routes, I can also say, give me an SSL certificate. It needs a cluster issuer, and I am, in this case, using let'sencrypt.org, which is a great service for providing SSL certificates for free. Wonderful. Point being, in conjunction with my ingress routes, I can request SSL certificates that will be trusted by people's browsers. So when you visit owncast.eom.dev or gitea.eom.dev or whatever else I'm running, you'll get the smiley face little lock and everyone's happy. Okay, that basically concludes all of the main services that are running in the background on this Kubernetes cluster. Once this is deployed, I manually, in my both routers, need to do this, port forward those HTTP routes to Ingress Nginx. Anyway. And actually, again, this script is a little bit out of date because we're missing the very last and potentially the most important step, which is the Ansible role for deploying each service. Those are living, well, they actually live, within the same repository they're here, but this is a submodule. I'm curious, is this going to bring me I don't like this. What's going on? I'm not going this way. Let's just do it the normal way. Shouldn't have done that. we're going here. Okay. No, this is where I just was. Sorry. That was scary. I don't know what that. I'm going to do that again later and figure out why did that say that, but it shouldn't have. Anyway, maybe it has like the git.eom.dev instead of git.eom.dev. But anyway, that's almost certainly what it was. Anyway, not important to you. This is a separate Ansible role. It's a submodule of software infrastructure, and it contains all of the tasks. Those are files, not tasks. All of the tasks required to deploy all of the services that are running here on my network. And I am not actually running all of these services. These are all things that I tried and was experimenting with. And most of them, I came to the conclusion I was either not going to host right now or was not going to host at all, either because I don't need them or because I didn't like them. Now, just so you can see it, I'll show you Gitea. Here's where Helm comes in. So Helm allows me to basically, I just add this Helm repo, I update my Helm repos, and then I deploy Gitea all in one big step with my entire configuration for Gitea defined in that step. All of this is the configuration for Gitea. So instead of having to open up a bunch of files and edit them and they just live on the machine on which they live, and then once it goes away, they're gone. The configuration for my Git server is source controlled, automated, repeatable. It's all right here. And it's the same thing for every other service that's running on my network. They all exist in these Ansible tasks, which makes this a very resilient network for updates, changes, restorations from a disaster, which don't happen to me very often, fortunately. Knock on that wood. Anyway, so talking about what services are deployed here is going to be very boring if we're just looking through these YAML files. So instead of that, I am going to switch over to some other websites to show you there. That being said, this is actually a very big screen in front of me. It's a 4K resolution, and the text can get kind of small. I'm zoomed in 200% here, and I'm probably not going to do that for the other ones because we don't need to read anything. So just a heads up. The first thing I want to show you is called phpLDAPadmin. phpLDAPadmin and OpenLDAP are a single sign-on service. It's a little bit more than that. It's a directory of resources. It's actually kind of confusing what OpenLDAP is and does, and even having used it a while, a little bit weird. So some of this I don't exactly want to show to protect the privacy of some of the people who are listed here, but basically what I do here is define what services are running on my network, who are the users of those services, what are the groups on the network, and things like that. So if we look at Gitea here, for example, I have a service account for Gitea. I can store the username, the email, some other useless stuff, passwords, any user information that I would want to save, I can put into OpenLDAP, which is accessible via phpLDAPadmin. And then my other services, such as Gitea, can use this as a single sign-on provider. So I can create my one user account here, and then create a group of Gitea users. Again, I'm not going to click on that to protect the privacy of... There is no one there. I can click on that one. It's just me. That one's fine. So I can create a group that says here are the users of Gitea, and then in my Gitea configuration, I can say use OpenLDAP as a backend authentication source. Admins are going to be members of this group. Users are going to be members of this group, and handles all of the sign-ins for my network. While I am talking about signing into Gitea, I just want to take a moment to note, if I open it in a private window, and I try to sign in, you can see sign in with GitHub. You can sign in with GitHub. You can use your existing GitHub account to log into my Gitea server, and I set that up so that anyone watching this or reading this or anything has the ability to open issues, leave comments, and things like that. This isn't like GitHub. You're not really going to be uploading lots of repositories here. But if you see an issue, you want to leave a comment or something like that, you can log in with Gitea or GitHub to Gitea. Okay, I just wanted to make that mention. So OpenLDAP is kind of the single sign-on provider for my network, and all of my services use this. In fact, I will go out of my way to find services that will use this. GitLab is kind of a more well-known and a more popular self-hosted Git server, but these OpenLDAP groups are behind a paywall. So, a basic functionality of OpenLDAP is locked behind a paywall in GitLab. That's why I'm using Gitea. They don't do that. They just let you use LDAP. And most of the services that I have looked at or even thought about, almost all of them support LDAP, at least for logins. Some of them try to put paywalls behind additional features, but that's a dumb way to run a business. That's a basic functionality of LDAP, and trying to put a paywall behind it, you're not going to last. Anyway, so LDAP, single sign-on provider, configure it right here with Gitea. We can use our groups, etc., etc. Okay, I think we get the picture there. I haven't really explained what Gitea is. Yeah, I have. We can see it. One thing I haven't talked about with Gitea, though, are Gitea actions. I'm losing my voice here, so I'm going to take a sip of water. Gitea actions is much like GitHub Actions. It allows you to create automations. And with my Kubernetes cluster, this will actually spawn pods that are dedicated to running whatever actions I define here. Haven't played with that very much yet, but in the future we will be using this hopefully quite a lot. Anyway, so we've looked at Gitea, we've looked at OpenLDAP. Let's look at Nextcloud. Nextcloud is like iCloud or Google, and it basically just gives us like file sharing, groupware stuff like calendars and notes and tasks and things like that. I've also deployed a Collabora server for editing documents in the browser, but the browser is kind of slow when I use it. Let's see, let's just open one so you can see it. This is the user manual I put together for Nextcloud here. But yeah, we have Collabora, so we can edit things in the browser. But I typically don't use Nextcloud through this web interface. Generally speaking, I'm on Debian with GNOME, and so I can do things like, let's see. This is probably going to be impossible to read given the resolution, but I can directly connect my Nextcloud account to my GNOME desktop, and it will synchronize calendars, it will synchronize files and contacts. I can pull up my Evolution planner here, and yeah, you can see that it all syncs with each of these desktops and across my devices. And the same thing with like the files and documents here. I can use LibreOffice to edit these documents without having to open Nextcloud in the browser. So it has a web interface, but it's not necessarily intended to be used with the web interface, or at least mine isn't. I have a few other apps that I've installed here for convenience, but like I think we kind of get the picture with Nextcloud. And for you, dear viewer, I'm not really making accounts for people I don't know on this, so it would be more interesting for you to host this yourself. If you do, this is a federated service, if you're familiar with what that means. So if you do host your own instance of this, we can interop, but we're going to move on from that for now. So Nextcloud is kind of like your Office suite of tools, and or your suite of Office tools. and Gitea is our Git repository hosting and automation. Owncast is this, my broadcast center where I am doing this, which brings us to Grafana. If you're familiar with networks of the sort that I've been describing here, Grafana will probably be pretty familiar. But I do want to point out that I was fortunate in that, where are my dashboards? Since I used very standardized things here, such as Prometheus Node Exporter on the hypervisor and Cloud Init on the virtual machine, along with that base Debian image, that comes with Prometheus Node Exporter built in. So I was able to use a publicly available standard dashboard, and this will provide me all the metrics I could possibly want on every machine that's running in the network, from hypervisor to virtual machine. You can even do like Kubernetes stuff on these. So like that's super cool. So this gives us some monitoring over the stats of our network, and monitoring is only good if you also have alerting. I've created a few alerting rules. We don't need to look at what they are. What's more interesting is where they go. We can see it here, element.eom.dev. Now this is a client for the Matrix protocol. Indeed, the Owncast chat I've decided to host on Matrix. I'm not going to log into this web browser here. And also, this is not a Matrix tutorial. So if you're not familiar with Matrix, I would recommend looking up what that is and how it works so that this will make a little bit more sense. Element is the client, and if I go to sign in here, Synapse is the server, and I am hosting both on my Kubernetes cluster. Now, I don't really use the web browser to access Element. I prefer to use a dedicated client, which is here. And what you can see is I have a DevOps room or space and an alarm room to which Grafana is posting its alerts. So we also have a self-hosted chat room. I have a few other things that I have connected with this. So like here's the Owncast chat. I can see that none of you are here, which is disappointing. That's okay. You'll be here in the future, I hope. We're good. Anyway. So yeah, I have a few other things here, a few other people that I have spoken to, and some of the rooms that I have created on this Matrix server are public. I have a Minecraft server, but yeah, some of the rooms here are public, such as this Owncast chat. That being said, I am not making accounts on my Matrix server for people I don't necessarily know. It's federated. So if you go to matrix.org, which I will do, they're not even paying me for this. Jeez. You know, unless they want to, they're welcome to. Yeah, see that? Donate. That's the spirit. I think they want it the other way, though. Why was I going here? That was too distracting. Yes, Matrix is a federated service. So if you have an account on matrix.org, similar to GitHub, you can sign in to your matrix.org account and then join these rooms. So you don't need an account on my platform in order to access the chat rooms that are on my servers. And that is Element. And I think that is the majority of the services that I have deployed. I do have more listed here, as you can see. Some of them are kind of background stuff, like databases and my OpenLDAP stuff. MinIO, we do want to see MinIO. But again, a lot of these are not running, or things that I deployed, tried, and then took down and I'm not using. So I'm only really showing you the stuff that I'm actually using. Keeping them here for reference, at least for now. MinIO, I think, is the last service that I want to show you here, and it's not very visual. Having trouble typing. All we see is this access denied screen. MinIO is object storage like Amazon S3. It allows me to create buckets and then put things in those buckets. I have one bucket called public, which is not access denied. this is really efficient uploads and downloads, and I have plans to use this, though I'm not necessarily using it very much yet. I had tried to do this stream on a previous date and was using this MinIO instance as a backend storage provider for Owncast, and that was causing actually poor performance for the stream rather than improved performance. You're supposed to connect it to an external S3 service, so that's kind of my own fault, but I can still use this. Very efficient uploads and downloads. I am planning in some way to store my live stream archive on MinIO for public access, though I haven't exactly figured out the way in which I want to do that. So for now, that is not what I'm doing. Okay, well, let's see. That is basically all of the services that I am running on this network, and I think we've seen enough of how it is running in the background with that big computer. The question now is, what exactly am I going to do with this? Well, there are many things that I can do with this, and in time I will probably do a lot of them. The first thing I am thinking of doing is this Kraken bot. This is a project I started a little while ago and was just kind of experimenting with automatic algorithmic cryptocurrency day trading on the Kraken platform. And I did get this working previously, and then promptly continued experimenting to its destruction. And so I think I want to pick this back up and try to make something that is reasonably profitable on the Kraken exchange. Just to give you an idea though, the algorithm this was running was just put all of your investment on what's currently doing the best. So it was just to get things up and running and to see if I could get these APIs working. Indeed it did. It's a good thing this isn't running anymore. It lost some money. That's fine. This is just kind of for fun. So I think I'll pick this back up, and what I want to do is first of all, fix the code so that it's actually making some reasonable action on that API and that exchange. I want to automate several things about this so that I can push updates to this repository and have it automatically build a new Docker image and then push that image maybe to a registry that I will self-host. And then the way this bot was working is that Kubernetes would pull down the image, execute it on a cron job, and then it would die. So, you can publish updates like that. Anyway, I digress. Incoming streams, I don't know how much I want to develop this on a live stream. I don't know how entertaining that's going to be, and I don't know how distracting that's going to be for me to be building and talking at the same time. Generally speaking, that doesn't always go great. So, at the very least, I'll be tuning back in on the live streams to do updates on how well this is doing and things like that. I also want to create projects. This is something I haven't used on Gitea yet. Creating projects, so we can kind of experiment with this of deploy KrakenBot. And then I can group together issues and organize a plan for what exactly is this going to do, how am I going to do it. Any users that would like to log in with GitHub are welcome to do so, open issues, and you're welcome to collaborate here. But yeah, I think the KrakenBot's going to be the next project here, and I will do some organization work and probably bring you back in once I have something more interesting to show other than myself typing. So I think that's going to do it for this first live stream. I'm going to upload this one to YouTube and probably to MinIO. And I think we'll see where it goes from here. So I'm going to count this as a success. I thank you for joining me. even though I can see the statistics on the viewers and they're quite disappointing. What a shame. That's okay. I'm not discouraged. So that'll do it for today, and I'll catch you back up when I have more to show. Thank you for joining me. Toodaloo.